So here we have a question, a feedback question that came up with a student of mine. And it's actually underneath it all, it's a fairly standard question that most of you would be able to answer it. It's just asked in a slightly strange way, and particularly what is effectively the ground speed is given to you in a format that you're not used to. And so what you're given is the track, 324 magnetic and drift, that's fine, variation, um, and then you're given a true airspeed, and instead of giving you a ground speed, you're given a tailwind component. Now, this can cause confusion more because this is not what you're used to than anything. The easiest way of dealing with this is just to apply the tailwind component. So we know a tailwind is going to increase the ground speed. So I'm going to add 30 knots to my TAS to find 450 knots. And so now we're into a perfectly standard wind calculation question. There is one exception in that we're asked for the wind magnetic. Now, of course, unless we're operating in the vicinity of a runway with the intention of taking off or landing, we don't really use magnetic winds at all in the real world. So we're not used to that. But what it does mean is that the variation is a complete red herring. And even though the flight computer, as you'll see, my favorite flight computer, the CRP5, does say heading true at the top, we will do everything magnetic on the flight computer. Usually I recommend that you use the flight computer true for consistency. But where everything is magnetic, it's just a waste of time. And just remember, if you've got all the details magnetic for now, and you want the answer to be magnetic, you may as well stay in magnetic. The same applies when you're doing wind components for runways. We use the wind magnetic for operating from a runway, and so we'll use the runway bearings magnetic, even though the flight computer says true. So let's have a look at how we do this with the flight computer. So we're going to need the track, the drift, the TAS, and the ground speed. That's the other thing that's slightly unusual is we've been given the track instead of the heading initially. So we are going to base this on track and drift, and obviously that will come out with the heading. I'm sure you've already seen that the heading should be 316 degrees magnetic, but we'll set in the track against the drift with the TAS and the ground speed and see what wind comes out. Okay. So we have the flight computer here on the high speed side of the slide, and so we need to set in the TAS first. Okay, remember, if you know the wind, put the wind in first, but we don't know the wind, so we usually, if we know the TAS, we're then setting the TAS in first. So that is our true airspeed of 420 knots. We then want true, it says true heading at the top, but of course we don't know heading or true. What we know is a magnetic track. So we're going to decide to sort of ignore the fact that that says true, and we're going to use this magnetic today. Okay, so ignore the true, and this is now going to be magnetic. And of course, we don't know the heading, so we're actually going to use the drift. Okay, we know there's 8 degrees right drift. I'll mark that in just for clarity here. Obviously, in the real life, you don't really need to do that. Just for clarity, I'll mark in 8 degrees right drift. And we know that the track is 324. So what I want to do is set 324 against the 8 degrees right drift. As I said before, I'm sure most of you jumped to the conclusion that the heading's 316. So we could have just set the heading in, but let's take the question as it's presented. So we have 324 then against 8 degrees of right drift. This is giving, of course, this is giving us a heading of 316, all magnetic, not true. Okay, and we've still got true airspeed there marked of 420. Now we want to mark the drift onto the face of the flight computer. So we've used the drift once, we're actually using it again. So I'm going to mark in 8 degrees drift. Of course, I'm marking it here because the ground speed was 450 knots. So I'm also going to mark in, sorry for the shaking my hands, mark in the 450 knot ground speed arc there. And then all we need to do is turn the flight computer so the wind mark is beneath the center bug, and we can then read off the wind direction here, which is giving us 214 degrees magnetic, and count down the wind speed. So that's 10, 20, 30, 40, 50, 60, just under 70 knots. It's hard to read to 1 knot with the high speed side, but the answer given in the question is 68 knots. Actually, the question answers are quite far apart, by the way, except for the speed. So the directions are tending to be quite far apart. The speeds are 68 or 64 knots, but we're looking at, I think, well, definitely 68 knots there. So 204 at 68 knots. Okay, so we found that the wind was 204 degrees. Everything was magnetic. So of course, that is a magnetic wind. And the wind speed was just under 70 knots. We know from the answers to the question that that was expected to be 68 knots. As I said, we can't really calculate it to that precision. Talking of precision, while I did get 204 degrees on that. That's the bearing of the wind is the least accurate of the measurements you're likely to do. Certainly, the wind vector is the shortest of the 3 vectors you're calculating, and so a relatively small difference in the position of your wind mark. I always do a cross, but your wind mark will give you a relatively large change in the wind direction. Excellent, thanks very much. If anyone's got any questions about this, just put them down below, or can contact me at the email address given at the beginning.